Okay, now we're going to talk about perfect square trinomials. So when we talk about perfect square trinomials, the reason they're called that is because when you factor them, they make these things right here. So you get something that is either something like, x plus 3 squared, or it could be 5x minus 7 squared, or it could really be anything. So when you see the factored form of it, it doesn't present itself as any kind of square numbers, but when they're expanded, right, just like the difference of squares of two squares, when they're expanded, it becomes a little more obvious, right? And so this is basically kind of what happens. Is you can tell what's happening and how we can factor it based upon what you see. And so let's just kind of look at these a couple examples. So I'm going to take a general example that I use a lot, right? And so that general example is this: is we're going to look at x squared plus 2x plus 1. All right. And for that matter, we could also do x squared minus 2x plus 1. Okay, and so the first thing hopefully you recognize is that this is a square number and this is a square number. Okay, same thing down here. This is a square number, this is a square number. Then the way you can tell it's a difference of two squares is you take this and you multiply it, and you take the square root of this, the square root of this, multiply them together. Well, the square root of x squared is x, right? The square root of 1 is 1. Multiply them together, all right, and that would give you, 1 times x, which is just x, and then double it. Well, if I double x, that means you just multiply it by 2, right? And 2 times x is just 2x. And if that happens to be your b term, then that is telling you, hey, this is a perfect square trinomial. And so, another, let's take another common example. I hope I'm not taking anything off your homework, and if I am, oh well, right? Here's a real common one. So it's x squared plus 6x plus 9, all right? So x is a square number, 9 is a square number, and you go, oh, okay, well, the square root of x squared is x, right? And the square root of 9 is 3. Well, multiply those two together, 3 times x, and you get 3x, right? And then if we double that, so if we go 3x times 2, we get 6x, and hey, look at that, right? So that's an example of kind of what it looks like when they're expanded, and that's what you're going to have to recognize. All right, now the difference between one that is subtracting and one is adding is basically just this sign right here. So when we have something, so let's kind of look at them side by side. So if I have x squared plus 6x plus 9, right? And we recognize that one. That's saying, well, that's going to be a plus b squared. So my a is square root of x, right? So that's x. My b is square root of 9, which is 3. So it's x plus 3 squared. And remember, that's the same thing as just this times itself, right? It's just exponents. And then now this version, right, is basically going to give me the same thing, except this tells me that I'm subtracting, right? So instead it's going to look like this. So they're almost identical except for this. So the b term is going to tell you whether it's positive or negative. If this is square and that's square, your b term is going to tell you, is this an x plus or an x minus, or whatever this happens to be. So you look for that to sort of dictate what that is. All right, and then that's how you factor it, right? So let's take a look at this first one here. We got m squared minus 10m plus 25. So I would look at this and say, I wonder if this is a perfect square trinomial. Well, let's take the square root of m squared. That gives me m, all right? So that's a perfect square. And then 25, the square root of 25 is 5, right? Okay, well, so far so good. Now let's multiply those two together, right? You go 5 times m and you get 5m. All right, and now we're going to double it. So if I go 5m times 2, right, that gives me 10m. And look at that, it's 10m. And so I know I'm going to have one of two choices here, right? So it's either going to be the a plus b or the a minus b. Well, my a is m. My b is going to be 5. All right. So that's when you look at this. And if this is negative, right? If this is negative, that means that we're doing the minus one, right? So this one is m minus 5 squared, right? A common mistake I'll see people make is that when they factor these, they'll go like this. They'll go m minus 25 squared. So they're recognizing that it is a perfect square trinomial, but they're forgetting that you have to take the square root of this, and that's the number you use, right? So because that would be a completely different perfect square trinomial. All right, now this one looks a little more confusing, but it's really, once you break it down, it's really not that bad. So if we take 9x squared, we take the square root of that, we get 3 from the 9, and then x squared square root is just x, right? So let's say, all right, so this is good. So 3x is going to be my a, right? So a is that. And b is going to be the square root of 16, right, which is 4. Okay, and so now multiplying together, so we go 3x times 4, and that's going to give me 12x, and now double it. So 12x times 2, because that's what the 2ab means, right? You're doubling. 12x times 2 is 24x. And do I have 24x? I sure do, right? And this is negative, so it's going to, again, be this form right here, except that my a this time isn't going to be just the x, it's going to be that 3x. So I'm going to have 3x minus 4 squared. All right? And so that's kind of what you're looking for. That's how these work. I'm spending a lot of time on these because I really want you to be able to recognize them. Okay? So good luck with everything.